So good day everyone. So this is our first video lecture on programming one with the topic um, computer programming concepts. So in this chapter, basically, you will be able to demonstrate understanding regarding computer systems, simple program logic, and the program development life cycle. Also, you'll be able to write pseudocode statements and construct flowcharts, differentiate the three basic structures, which primarily is essential in programming, which is sequence, selection, and looping. Okay, so let me share with you my screen. So I already have instructed you to, of course, download a compiler for our laboratory exercises later on, and you can do it. You can have it online, or you can have it sa inyong smartphone. But also, it requires internet connectivity. Okay. So here's the first chapter of our call this video lecture, which is about computer programming concepts. So basically, this is your first programming course. Okay, so you'll be able to appreciate all constructs and program logics, which is essential in doing programming. So this is the foundation of your programming journey. So you have to focus on understanding the structures that is required in doing programs. Okay, so that so that when you shift to other programming languages, you'll be able to understand and you'll be able to. Okay. So to start with this specific course, we need to understand what computer systems is. Okay, so when we say computer systems, these are the components that work together to obtain a specific output. Okay, in case of computer system, it this is the entire what do you call this tools, components that are required to for the system to work. Okay, so components like hardware and software. So these are the basics. Okay, so when we say hardware, okay, these are all the tangible components of the computer. This includes your mouse, your keyboards, the speaker, and printers. So everything that you can actually touch are in the computer system is considered to be hardware. Okay, so even the internal parts of the computers is considered to be the hardware. Okay, so when we speak about the other component, which is software, so these are actually the programs which you use, okay, which you give instruction with in the computers and to the things that it wants to do. Okay, an example of this would be your office applications, your programming language development tool. Okay, you also have your web browsers. Okay, and there are several categories of softwares, okay, which you will learn in your introduction to computing. Okay. So software can be classified into two broad types. Okay, we have first is the application software, and we have the system software. So when we speak about application softwares, these are actually programs that allows you to make a task. So for example, we have your presentation software, you have your word processing software, your spreadsheets, your um, web browsers, your video editing tool, your software. So these are all application software. So it allows you to do things with your computer. Okay, that makes our computer usable. Okay, so when we there's an excerpt here. So when you hear people say they have downloaded an application, maybe in your mobile devices, they're simply using an abbreviation for an application software. So everything that you install in your computers are actually application software. But of course, there are also utility softwares, which includes your drivers, your middlewares. Okay, but they are still considered to be part of the software system. Okay, so when we speak about system softwares, are these are actually our programs. These are programs that you use to manage your computer. So you can have your operating systems, which includes maybe the most popular is the Windows-based um, systems. You have your Linux, and you also have your Unix. Okay, and there are you have your Android, and of course Apple iOS. Okay, for Mac, they are using Mac operating system. So system software actually um, is the one responsible in bridging our application software together with our hardware. So without this system software, okay, we cannot be able to run our system, our computer, okay, because this requires our computer to work, okay. So that's system software. And when we speak about programming, it's actually a term that allows us to write software instructions. So when we say programming, we are going to write programs or software. Okay. So together, computer hardware and software accomplish four major operations. We have the input, the processing, the storage of data, and we have the output. Okay, so when we say input, so data items enter the computer system and are placed in memory where they can be processed. So hardware devices that perform input which includes keyboards and your mouse. So through these devices, data or are entered in our computer system. Okay, so when we speak about data items, this includes all the text, numbers, and other raw materials that are entered in and processed by our computer. Okay, so first thing to do is, of course, you need to provide input for the computer to process. So when we say processing, okay, processing data items involves organizing, sorting, checking, and performing calculations. So the hardware component that performs these tasks are, of course, is the central processing unit, or our CPU, which considered to be the brain of our computers. Okay, so all data are processed by our processor. Okay, which also requires storage. Okay, and when you have provided an input and try to process it, of course, you are expecting for an output. Okay, an output can be in a in a form of graphical user interface. So everything that you see in your monitors, okay, your printed outputs, like for example, you print documents. So the output there is your a hard copy of the documents. Okay, and for example, you allowed to or you open a video or you watch a video. What you can see there, the output there are of course the sound and the video itself. Okay, so programming professionals often use the term data for input items, but use the term information for data items that have been processed and output. So meaning when you are able to process already data, there you can have information. So information are actually useful things which you can get an idea within too. Okay, so that's why it's called information. It's already processed and you can gain something from it. Okay, for storage, sometimes you place output on a storage devices. For example, your pen drive, your um, cloud device, your external hard drives, or even the hard drive itself, or in your computer. Okay. So when we say cloud, cloud refers to the devices at remote locations accessed through the internet. Okay. So that is the four um, uh, operations of a computer. So we have input, we have processing, we have output, and storage. So this is the basic. And others includes other operations like maintenance. Okay, but these are just the four major functions. Okay, so in programming, of course, you are going to write set of instructions to tell the computer what to do. So there's a tool that you need to use, and that is actually your programming language. Okay, so programming language allows you to write computer instructions in a computer programming language, or in a way that your computer can understand and process. And those are the tools that you are going to use when you develop programs. Okay, so in this specific programming course, we are going to use Visual Basic. Okay, and there are other programming languages like C Sharp, which and C++, and this is part of the Microsoft system ecosystem. Okay, we have also Java, which is part of Oracle, and this is free of use. We have the old one, which is the COBOL. There are actually other programming languages which you can use, like scripting languages. You have your PHP, your Python, and your Kotlin, okay, which are also programming languages. Okay, regardless of what programming languages which you are going to use, the important thing there is you know the basic structure on how to develop programs using this what you call these programming languages. So it is important for you to focus on the foundation structures of programming, which you will learn in this specific course. Okay. So the instructions you write using a programming language are program code or a program segment. So when you write instructions, you are actually coding the program. So every programming language has rules governing its word usage and punctuations. So these rules are called the language syntax. So mistakes in a language usage are actually syntax errors or bugs. Okay. So we'll show you some a sample line of code in every programming language that we have. Okay, so we have here, for example, here Java. We have here a statement that outputs or displays hello on a single line. So we have here in Java system.out.println. Okay, so in C++, when you output, you use console output or cout. Okay, in Visual Basic, you use console.writeLine, and in Python, you use print. In COBOL, you use display. So all these syntaxes are differs from each of the programming language. But okay, as long as you know that this is for output, then you can use this in you have the idea that this line of code is for printing or accept or displaying output or accepting input. Okay, so we have here computer memory or random access memory. So RAM for short, it is where your program instructions are stored, okay, utilized by your central processing unit. So when you talk about how a specific process being undertaken, okay, in the entirety, so this is actually in part of operating systems. Okay, so all of these components of the computer work together to have a common output or to provide an output for your system. So RAM is considered to be a temporary storage. Okay, and this is a form of a volatile memory. So internal storage is actually volatile. Its contents are lost when the computer is turned off or loses power. So there are questions why RAM is used when processing. The RAM is used to store data for processing. This is because RAM provides faster processing than the ROM. Okay. So on the other hand, we have the ROM or the permanent storage devices. These are actually non-volatile. So that is their contents are persistent and are retained even when power is lost. Okay. So for example, there are your drive Ds and drive Cs. Okay. So when you turn off or your PC, when you turn it on again, you can see the data which you save in this specific storage device. Okay, so after a computer program is typed using programming language, statements are stored in memory and it must be translated to machine language that represents the millions of on and off circuits within the computer, or we say the binary system. So number system, okay, which is consists of ones and zeros. These are actually just the thing that the computer understands, only ones and zeros. So you have machine language. Okay, source code, we have two codes. We have source codes. These are part of a programming language statements, and we have the object code, which translated the machine language statements. Okay, so when say compiler or interpreter, so this is a piece of software that is being used by programming languages. So this translates source into machine language and tell you if you have used your programming language incorrectly. Therefore, syntax errors are relatively easy to locate and correct. So the compiler or interpreter you use highlights every syntax errors. Okay, so you have your object code and your source code. Your source code is a non-execute. These are non-executable, so you can just modify it. So object code, these are actually a translated code to which your computer can understand. Okay, if there's an error of your code, basically your program will not run, or if it will run, it will not give you the exact or the correct output which you want that specific program to do. Okay, so for example, to illustrate, so for example, there's a function to greet, and you want um, to print hello world. Okay, and if the compiler translate that, okay, into a machine language, so it then converts to a series of ones and zeros. Okay, and the simplest definition of a compiler is a program that translates code written in high level programming language, okay, so into a low level code like assembly and directly executable by computer or another program such as virtual. Okay, so Visual Basic, C Sharp are actually high level programming language. Okay, so you don't need to worry about converting because there's already a compiler that is responsible in converting your programming codes or your codes into executable codes or a code that the computer can understand. Okay, so we now move on to understanding simple program logic. So when you say program logic, okay, or when you programming, there's actually a logic that you develop. Okay, so in order for a program to work properly, you must develop correct logic. Okay, which you must write program instructions in a specific sequence. Okay, so there will be you need not to include, of course, erroneous codes or instructions. So everything you program are actually instructions to the computer, okay? And that creates logic, right? So a program with syntax errors cannot be translated fully and cannot execute. So a program with no syntax errors is translatable and can execute, but it still might contain logical errors and produce incorrect output as a result. All right. So you cannot go away with errors when doing program. Okay. So when you learn the program development life cycle, okay, and then you can see there part of the process is testing and debugging. So that's one way of correcting your error. Okay. So here we are with the program development cycle or program development life cycle. Okay. So the first thing to do is to understand a specific problem. For example, if you are going to add two numbers, so what you will use, of course, is you need to get input two numbers and you use addition, and that's your problem, how to get the sum of specific numbers or two numbers. Okay, and then right after that you plan the logic. So how will I write the instruction? Okay, so you have to plan the logic, and part of that is making pseudocodes, making flowcharts. Okay, and then when you have already the logic on or the way you want to answer that specific problem using your programming code or your program code, then you now have to write the code. And that code is specific to a specific programming language that you use. Okay, so you use the proper syntax in um, doing that specific program logic. Okay, so you now write the code. After writing the code, you translate the code. Translate the code includes building okay, or compiling the program which you have developed or write. Okay, so after that, you are going to test the program. Okay, after that, you put the program into production or you build the program. And of course, part of that is maintain the program, which is the last phase. Okay, to dig deeper with this cycle, okay, um, you have to understand the problem first. Okay, so a programmer's job involves writing instructions. Okay, and but professional programmer usually does not just sit down at a computer keyboard and start typing. So the programmer's job can be broken down into at least 7 steps. Okay, so first is understanding the problem. So in this specific scenario, the programmer must first understand what the users want in a form of maybe interview or requirements elicitation or requirements identification. Okay, into which you will ask the user what to do or what is the specific problem that you want to address to and you want to make program with. Okay, so you can read this real life scenario in understanding a problem. Okay, so second one is planning the logic. So planning the logic is the heart of the programming process. So programmer plans the steps of the program, deciding what steps to include and how to order them. Okay, so you have to understand the things that you want to do and try to um, make use or identify the deliverables and by developing the logic. Okay, so two common planning tools are actually flowcharts and pseudocode. Okay, so both tools involve writing the steps of the program in English. Okay, so in programming, there's actually, of course, a process on how are you going to solve that specific problem. Okay, and that is on how you plan the logic. So you use flowcharts and pseudocode. Okay, so that's checking. So when you have your flowcharts or your pseudocode, so you have to identify your inputs and outputs. So desk checking is actually a process of walking through a program's logic on a paper before you actually write the program. Okay, so it's a good idea that you desk check so that you will determine the or how your program will work when you write it in your programming language. Okay, so you will identify there your input and how you process it, and of course the expected output. Okay, so you may hear programmers refer to planning as a development or developing an algorithm. So an algorithm is the sequence of steps or rules you follow to solve a specific problem. So in your higher level programming course later on, you will encounter algorithms, and algorithms are actually process or the sequence, a finite sequence that that specifically address a specific address to solve a problem. Okay, so that's an algorithm. So just for example, an algorithm to uh, cook rice. So how do you cook rice? There's actually a sequence of steps. Okay, and you create an algorithm of that, and that's basically an application of algorithm. Okay, or for example, an algorithm to solve or to get the sum of two numbers. Okay, so you write the sequence, and then you create its algorithm. So step by step, step 1, step 2, step 3. Okay, so after planning, okay, you now try to code. Okay, so one of the challenges, or the drawbacks, or challenges I should say, in doing programming, programmers tend to just write and write and write the code without planning. So they skip planning. That's why it's relatively difficult for them to address the problem they want to solve. So as a reminder, you always need to plan the logic before actually doing the code. Okay, so coding the program, so it is where it's the programmer choose a particular programming language, okay, and translate the algorithm into a code, okay, which will be written in that specific programming language. So coding is a technical word for writing the program, okay, and you will do coding later on in your activities. So for is using the software to translate the program into machine language. Okay, so there's a process of when you write the program, you compile. When you compile, you will what do you call this? The the compiler will then determine if there are erroneous codes, and will basically inform the developer of the programmer that there are errors in the program they or the code that they write in the programming language. Okay, so translating the program is actually a series of compiling, testing, and running the code. Okay, so so in that specific case, when you compile, you'll make an object code, which of course the code that translate into machine language into which the computer can understand. Okay. So for example, you have here high-level programs. Okay. We have here class. Okay. We have here low-level program. Okay. Or the assembly language, and we have the executable machine code, okay, which is already converted the program to series of ones and zeros. Okay, so here's an example of syntax and logical errors. Okay, so what's good in programming languages is that when you try to write codes, it automatically determines whether there are syntax errors or logical errors. Okay, because as we have said kanina a while ago, that a specific programming language requires a specific syntax in writing the codes. Okay, some other programming language have the same structure in building or writing a code. Okay, fifth, we have testing the program. So testing the program allows you to determine whether there are errors, or is your program is doing what is supposed to do. Okay, so that's testing the program. So when you write your programs later on, or systems later on, it will undergo from to a series of testing. Okay, and as you write, you debug and you correct the errors. Okay, so testing, we have also unit testing, beta testing. Okay, when you already have developed your program, there's a series of unit testing and beta testing before it will be deployed in to by your clients, or upload it maybe for utilization of the expected users. Okay, so next is putting the program into production. Okay, putting the program into production means you already all started building the program or the system which you have developed, and try to so that the users or the clients or the end users will be able to utilize the program you do. Okay, for example, you have your office, you have your web browsers. Okay, these are actually programs. Okay, but of course you will not yet build your systems here in this programming course, because this is just your building blocks or your stepping stone in doing such activities later on. Okay, and lastly, you have maintaining the program. Okay, so maintaining the program allows you to include updates and try or include other features which you want to incorporate, which have not been included in your first production. Okay, if there are errors, unexpected errors, you are going to maintain the system. Okay, so using pseudocode statements and flowchart symbols. So part of programming logic, or the planning the logic, is using pseudocode statements and flowcharts. So pseudocode are actually English-like instruction, which is actually near to like the exact programming code which you are going to utilize or use or write in your programming language. Flowcharts, on the other hand, is a graphical representation of the process of your inputs, your outputs, the process. Okay, it's a graphical representation of your algorithm, okay, or your steps or sequence in solving that specific or problem. Okay, these are actually called to be blueprints. Your flowcharts are actually called to be the blueprint of your program. Okay, so for example, when you write a pseudocode, okay, there's always a start or beginning, and you have also a stop or end. Okay, for example, we have here input. The following 5 statements constitute a pseudocode representing of a number doubling problem. So of course, you need to start the procedure. Okay, and the thing that you need to do is you want to input a number. Okay, so after inputting a number, so your answer, you are going to assign that number to my answer, which you already have to multiply the number by 2, okay, because doubling problem, okay, and output my answer. So that's your pseudocode. Okay, input a number, assign the result of my number multiplied by 2 to my number multiplied by 2 to my answer, and output my answer. Okay, using pseudocodes involves writing down all the steps you will use in a program. Usually programmers preface their pseudocode with a beginning statement like and then start, and end with terminating statement like stop. Okay, the statements between start and stop look like English and are like are indented slightly so that start and stop stand out. Okay, so pseudocode is fairly flexible because it is a planning tool and not a final product. Therefore, for example, you might prefer one of the following: Instead of start and stop, you use begin and end. Instead writing input my number, so some developers would like to get my number or read my number. Okay, there are several since this is an pseudocode is an English like instruction. Okay, you can use English like statements in representing your pseudocode. Okay, as long as you understand the how that sequence address a specific problem, it's okay. Okay, so next is drawing flowcharts. Okay, so there are actually in drawing flowcharts you actually have symbols to use. Okay, you have here your parallelogram, okay, which represents an input symbol which indicates an input operation. So you write an input statement in English inside the parallelogram. For example, you have the input my number, output my answer. So to represent an output statement, use the same symbol as for input statements. Okay, for process, you use actually a rectangle. Okay, so rectangle represents a process in flowchart. And of course, you have flow lines. Flow lines allows you to direct the sequence of your flowchart, okay, on how you specifically address your, or how to specifically address a problem, okay. You have also decision, okay, which is a diamond, okay. You also have preparation or initialization. You have your symbol, and you have your terminal, which is actually like oblong or rounded edges rectangle. Okay, so that's what do you call this, a terminal. Okay, you represent their start, stop, begin, or end. Okay, so those are ways for you to create or plan the logic of your program that you want to do. Okay, you can use flowcharts or pseudocode. So if you're comfortable using pseudocode, then you may use pseudocode. If you're comfortable to use flowchart, then it's you use flowchart. Okay, now in programming there are actually three basic structures. Okay, when you say structure, this means that it's a basic unit of programming logic, and its structure is a sequence, selection, or a loop. Okay, sequence, selection, or decision, or a loop. So first one is the sequence structure. So sequence structure allows you to run the program in sequence, so it's procedural. Okay, how you specifically write the code, okay, it will read that line by line. So that's what we call sequence. So there's no alternate code to be executed, or there will be no codes that will not be executed. Okay, so that's sequence from code 1 to code 10, 11, 12, 13. Okay, so that's sequence. So here's an example of flowchart doing that. Okay, so you have your start. You initialize number, length, width, and perimeter, and you have your input length and width. So for you to get the perimeter, you have to multiply 2 times length plus 2 times width, and then you output the perimeter. So that is the sequence. Okay, it starts from line 1 to line n, or how many lines of codes you have. Okay, that's sequence structure. Selection structure on the other end, or decision structure, provides you as an alternative code to be executed, or a code that is not to be executed when a certain condition is met or not met. Okay, it allows you to choose what code to be executed. So that's selection. Okay, so there's actually a Boolean expression that you are going to test whether if given that a certain condition or Boolean expression is evaluated. So when say Boolean expression, no, it um, it is a statement or expression that returns a value of either true or false. Okay, so given if it will give a true result, it will execute a specific line of code, and if the Boolean expression returns false, it will execute other code other than the codes that is supposed to be executed when the Boolean expression is true. Okay, so to show it up to you, for example, you have here, if some condition is true, then do one process, else do other process, and you have to end if. Okay, example here, a payroll program that might include such statement. Okay, if hours work is greater than 40, so meaning if the hours work is greater than 40, then it will only execute this it will only execute this line of code. Okay, so otherwise, if hours work, okay, if hours work is not greater than 40, okay, it will execute the else statement, or it will execute other statements, okay, which is in this case it will execute this line of code. Okay, so that's decision or selection. You are going to select what is specific or decide the specific block of codes you want to execute. So that's decision or selection structure. Okay, so we'll learn that in chapter 3 and 4 of this programming course. Okay, this is fundamentals. All right. So there are actually alternatives. Okay, if there are no alternative code, then meaning there's no code to be executed. If there's a single alternatives, meaning there are codes that will be executed. Okay, so here's an example of the flow chart or the flow of a specific decision structure. Okay, the other structure is the loop structure. Okay, so a loop, when you say loop or iteration, okay, so it will specifically execute the block of codes number of times. Okay, and you use loop structure on that. So in Visual Basic, you actually can use for or while loops, or you can even have for loops or do while loops. Okay, so you will know this as we go through this course. Okay, and loop, it will execute, when you say loop structure, it will just execute the block of codes number of times, or several time. Okay, so that's why it's called a loop. Okay, so here's an example. You have your while, do while. Okay, and this specifically shows the structure of flowchart of a for. Okay, so in this specific flowchart, no, it allows to run the program as long as the number is greater or less than 100. Okay, so and there's here an update statement. Okay, so you increase the number into 10 every time you loop. So if this is less than 100, and if you input a number here, for example, 5, meaning you will add 10 every time you iterate 5, and we will test whether your updated my number is still less than 100 for you to again repeat the process. Okay, so loop several times. So in this case, if you input 5, after first iteration you have 15, next 15, 25, 35. So expected that 105, when the number of my number is 105, meaning, or it's already greater than 100, it will already terminate the loop. So it will get out of the loop. Okay, so that is loop structure. So I think that would be, this is another example, okay, of a loop structure. Okay, and I think that's basically the end of this specific video lecture. So the next video lecture will be now understanding the code in, or understanding or doing the code in Visual Studio. Okay, so do you have, for those who are present here,